Problem number 1.71. A pulley is fixed to a ceiling of an elevator car that carries thread whose ends are attached to loads of mass M1 and M2. It means there is an elevator. In this elevator there is a pulley and two masses are there, M1 and M2. Okay. And now this problem is saying that this cart starts going up with the acceleration omega naught. Okay. There is no friction. We are neglecting all other factors. Now we have to find out acceleration of load M1 and M2 with respect to elevator shaft, which means it's a point at rest. Okay. And second, the total force exerted by the pulley on the ceiling of cart. Okay. So first of all, we need to draw free body diagram of mass M1 and M2 with respect to this cart. Okay. So our first calculation is with respect to cart. Okay. So this cart is a non-inertial frame as it is accelerating upward with acceleration omega naught. Okay. So here we need to consider effect of pseudo force. Okay. So let's suppose tension in this string is T. So the free body diagram for mass M1 would be, mass is M1. There is a force due to gravity M1 into G and a pseudo force because frame is non-inertial. So this is M1 into omega naught and tension is T. And this is moving with an acceleration omega. This omega acceleration is with respect to cart. Okay. And similarly for second body, mass is M2. There is a gravitational force M2 into G, a pseudo force M2 into omega naught and a tension T. And if first one is moving upward, then second one will move downward. Okay. So now we can write equations of motion with respect to these free body diagrams. So for first body, it is T minus M1 plus G plus omega naught is equals to M1 into omega. Equation number 1. For second body, it is moving downward. So these forces are greater than tension. So we can write M2 G plus omega naught minus T is equals to M2 omega. This is equation number 2. Now we'll combine these two equations, just simple mathematical manipulation. Then this T will get cancelled out. Okay. And from here we'll get M1G plus M2G. This, okay, let me write minus M1G plus M2G because this is negative sign, plus M2 omega naught minus M1 omega naught, and this is equals to M1 plus M2 into omega. So if we'll rearrange this, then we'll get omega is equals to M2 minus M1G plus M2 minus M1 omega naught divided by M1 plus M2. So here we have got the expression of acceleration with respect to this cart. Okay. But as per the question, we have to calculate acceleration with respect to this shaft, which is stationary. Okay. So for that, we need to draw frame of references. This is your shaft. Okay. And we can consider this is frame of our cart. Okay. So with respect to this shaft, cart is moving with acceleration omega naught, which is already given, and this is, let's assume, mass M1. Mass M1 is moving with acceleration omega. We already calculated this. Now we have to calculate this acceleration omega 1. Okay. So from vector sum we can write omega 1 is equals to omega naught plus omega. Okay, and we already have omega, so you can put here. So omega 1 is equals to m2 minus m1 into g plus a naught or omega naught. Okay, because m2 and minus m1 is common, so we can take it out, upon m2 plus m1 plus omega naught. Okay, so we can simplify this expression further just by multiplying m2 plus m1 here. So this is m2 minus m1 into g plus m2 minus m1 omega naught from here and m2 plus m1 omega naught from here. So we may write 2m2 omega naught upon m1 plus m2. Okay, this is answer of first part. Okay, now second part is the force exerted by these blocks on this pulley shaft here. Okay, so if we look at the free body diagram, then the net force is 2T. Okay, so our objective force is 2T here. Okay, and from equation number 1 we can figure out T. Okay, so if we look at the equation number 1, then we can write 2 times m1 omega plus m1 into g plus omega naught. Okay, and we already have omega, so we can substitute here. So this is 2 and m1 into, in bracket, m2 minus m1 g plus omega naught upon m2 plus m1 plus m1 into g plus omega naught. Okay, so this part get multiplied here on this side, so we need to open this expression here. So if you open, then from the very first part we'll get m1 m2, 2 is outside, m1 into m2 minus m1 square, and this is g plus omega naught, and from this equation we'll again get m1 into m2 plus m1 omega naught with positive sign, m1 m2 plus m1 square, and again same term, let me write here, g up omega naught upon m1 plus m2. So here you can see m1 square and m1 square will get cancelled out. We'll add these two terms, so we'll get 2 m1 m2, 2 is already outside here. So final answer is, I can write here as there is no space. So this force is 2 times of this, so 4 times m1 into m2 g plus omega naught upon m1 plus m2. This is final answer of second part.